So hi everyone, in today's class we'll talk about again electrophilic substitution reaction. Electrophilic substitution reaction. So the second example here now, nitration of benzene. Nitration of benzene. In this case, benzene is treated with concentrated HNO3 plus concentrated H2SO4, and the product we get here nitrobenzene and H2O as a byproduct, nitrobenzene. Here benzene ring is oxidized also, so it is an example of that is redox reaction also. Benzene ring oxidized in this case. So product we got here nitrobenzene. Now its mechanism portion. So first step will be here generation of electrophile. Generation of electrophile. H2SO4 gives proton, and then there is protonation of nitric acid. Protonation of nitric acid. So here we get protonated nitric acid. This is protonated nitric acid. And here water is lost now, and we get here nitronium ion as an electrophile, or we can write it like this also, NO2 plus. So nitronium ion here is an electrophile. Its name is nitronium ion. Nitronium ion. In the second step, this nitronium ion is going to target benzene ring to give carbocation as an intermediate. A wheeled intermediate we will get, and after that removal of hydrogen. The third step will be there, the removal of hydrogen in this case. So this one is first step. Second step, here it will be second step, attack of NO2 plus, that is a nitronium ion, on benzene ring. Here one CH bond is already there. Now this NO2 plus will attract pi electron to give here a carbocation. So this intermediate we are getting in the form of carbocation. It is resonance stabilized, that is this bond will be shifting here. So positive charge on this carbon, then this is shifting here. So positive charge on this point. Now equivalent of these three gives us this resonance hybrid structure. This is a wheel-end intermediate. It is called wheel-end intermediate. And in the third and final step, this removal of hydrogen will be there, and we will be getting nitrobenzene. Here this step is considered slow step. This is slow step when electrophilic attack is there. So rate will depend on the concentration of benzene and this nitric acid. It is actually coming from nitric acid NO2 plus and sulfuric acid also. This sulfuric acid will be acting as here dehydrating agent also. That is when water is lost. So this water is absorbed by this concentrated H2SO4. Nitric acid cannot absorb this water molecule, but it can act as dehydrating agent. So purpose of taking H2SO4 is this here. So third step here, the removal of H. So finally, we are getting here nitrobenzene. The third and last step here. As I told you earlier, concentrated H2SO4 act as dehydrating agent. Dehydrating agent. And this is also an example of redox reaction. Here benzene ring is oxidized to give nitrobenzene. After this, the third example I will consider sulfonation of benzene.